Good day each and everyone, especially to our dearest course professor, Mr. Christian Caben Larisma. So today I will be your second reporter and I will discuss about mathematical induction. So I am Alan Martin Roche Breldo. Before we start our lesson for today, I have here our intended learning outcomes or the ILOs. So at the end of the session, the MAED mathematics students should prove propositions by mathematical induction. Again, our intended learning outcomes for today or the ILOs. So at the end of the session, the MAED mathematics students should prove propositions by mathematical induction. So, principle of mathematical induction or PMI are also commonly known as mathematical induction. So, mathematical induction is a standard procedure for establishing the validity of mathematical statements, which we shall call propositions involving series of positive integers. So, meaning, mathematical induction is used to prove propositions involving series of positive integers. So the principle of mathematical induction or the mathematical induction, it is a mathematical proof technique. It consists of 4 steps. These are the following. So again, in mathematical induction or principles of mathematical induction, there are 4 steps. So first step is show that it is true using when n is equals to 1. Again, show that it is true when n is equals to 1. Second step, assume that it is true for n is equals to k. Third step, show that it is true when n is equals to k plus 1. And then last step is conclusion. Again, there are 4 steps in mathematical induction. So first step is show that it is true when n is equals to 1. And then second, assume that it is true for n is equals to k. Third, show that it is true for n is equals to k plus 1. And then last step is the conclusion. So step 1, show that it is true when n is equals to 1. So in this step, we verify the validity of proposition for a few particular cases of n. We start with the smallest value for n, for which the proposition holds. Usually, we use n is equals to 1, unless otherwise stated. So, in step 1, we substitute 1 for n, unless otherwise stated. And then, second step is that assume that it is true for n is equals to k. So, in this assumption, made carrying out a proof of the induction. This means that we have to assume that the statement is true for some positive integer n is equals to k. So we simply substitute k to n in the second step. And then step 3, show that it is true when n is equals to k plus 1. So and this is the basis of induction, where a hypothesis is utilized to carry out the desired result. Meaning, so we will substitute k plus 1 to n. And then the last step is the conclusion. This proposition is true for all positive integral values. So, conclusion, so we will generalize this one. And then we simply prove that the principles of mathematical induction is true. Then, all positive integral values is true. So you must in the conclusion and show that it is true when n is equals to k plus 1, it should be the same. So if it's the same, step 3 and step 4, the answer is the same. Therefore, the principle of mathematical induction is true. For example, here, prove that 1 plus 2 plus so on, n is equals to n times n plus 1 over 2. So step 1, again, show that it is true when n is equals to 1. So we simply substitute 1 to n. For example, here, 1. So 1 is equals to 1 times 1 plus 1 over 2. So 1 plus 1 here is 2. So 1 plus 1 is 2 times 1 is equals to 2. So 1 is equals to 2 over 2. 2 divided by 2 is equals to 1. So 1 is equals to 1. So therefore, it is true when n is equals to 1. So, second step, assume that it is true for n is equals to k. So, we simply substitute k for n. So, 1 plus 2, n is equals to n times n plus 1 over 2. Simply substitute, so it becomes k is equals to k times k plus 1 over 2. And then the third step, show that it is true for n is equals to k plus 1. So, n is equals to n times n plus 1. So, we substitute k plus 1 to n. So, it becomes k plus 1 is equals to k plus 1 times k plus 1 plus 1. We simplify that one, it will become, so k plus 1 is equals to k plus 1 times k plus 1 plus 1, it becomes k plus 2 over 2. So, the answer of n is equals to k plus 1, k plus 1 is equals to k plus 1 times k plus 2 over 2. And then, last step is the conclusion. So, again, if step 3 and the step 4 is the same, so therefore, the PMI is true, or the mathematical induction we used is true. So, in the conclusion, 1 plus k plus 1. So, in this step, we add k plus 1. So, it becomes is equals to k times k plus 1 over 2 plus k plus 1. So, we simplify this one. So, we add k times k plus 1 over 2 plus k plus 1. It will become k times k plus 1 plus 2 times k plus 1 over 2. So, we simplify that one. So, here, k times k, it will become k squared. And then k times 1 is k. Plus, 2 times k is 2k. Plus 2 times 1 is 2. So, over 2, simplify that one. So, it will become k squared plus 3k plus 2 over 2. So, this one, we can factor this one. So, it will become k plus 1 times k plus 2 over 2. So, in this step, and then in the third step, which is show that it is true for n is equals to k plus 1, as what you observe here, and the conclusion is the same. So, therefore, it is true using PMI or using mathematical induction. So, another example number 2, show that 1 over 1 times 2, then 1 over 2 times 3, 1 over 3 times 4, so on and so forth, with the general formulas of 1 over n times n plus 1 is equals to n over n plus 1. So, first step, show that it is true when n is equals to 1. We substitute 1 to n. So, it will become 1 over n times n plus 1 is equals to n over n plus 1. So, here, substitute. So, it will 1 over 1 times 1 plus 1 is equals to 1 over 1 plus 1. So, here, 1 plus 1 is 2. So, 1 over 2 times 1 is equals to 1 over 1 plus 1 is 2 is equals to 1/2. So 1 over 1 times 2 is 2. 1/2 is equals to 1/2. Thus, it is true when n is equals to 1. And then, assume that it is true for n is equals to k. So, substitute from 1 over n times n plus 1 is equals to n over n plus 1. It will become 1 over k times k plus 1 is equals to k plus 1. And then third step, show that it is true for n is equals to k plus 1. So 1 over n times n plus 1 is equals to n over n plus 1. So we put k plus 1 to n. So it will become 1 over k plus 1 times k plus 1 plus 1. So as here, equals to k plus 1 over k plus 1 plus 1. So we simplify that one. It will become k 1 over k plus 1 times k plus 2 is equals to here k plus 1 over k plus 2 because 1 plus 1 is 2. So it will become k plus 2. And then last step is the conclusion. So from 1 over n times n plus 1 is equals to n over n plus 1. So here we plus k plus k plus 1. So here is what you can see. So k plus and then k plus 1. So it will become 1 over k plus 1 here. And then 1 over k plus 1 plus k plus 2. Here. So here we simplify this one. So k over k plus 1 plus 1 over k plus 1 times k plus 2. So it will become, so we simplify that one, k times k plus 2 plus 1 over k plus 1 times k plus 2. So this one, we simplify this one, so it will become k times k is equals to k squared. And then k times 2 is 2k plus 1. And then k plus 1 over k plus 1 times k plus 2. So factor this one. So it will become k plus 1 times k plus 1 over k plus 1 k plus 2. So here we can cancel the k plus 1. And then the remaining is k plus 1 over k plus 2. So in step 3, it's the same. So in step 3, it's the same here. K plus 1 over k plus 2. And then step 4, k plus 1 over k plus 2. So therefore, it is true using mathematical induction or the principle of mathematical induction. So again, there are four steps and principles of mathematical induction. First is show that it is true when n is equals to 1. And then second, assume that it is true when n is equals to k. Third is show that it is true when n is equals to k plus 1. And then last is the conclusion. So here, evaluation, prove the following using principle of mathematical induction or PMI. So I hope that you learned today. I hope that you learned something today. And please answer the evaluation and then send it to our course professor on his email. So thank you so much and God bless us all.